Welcome to all. Here we are going to learn the CHI 130 course main group element. Our today's topic is interhalogen compound. What is the interhalogen compound? Here the two different halogens which can be react together. There is a formation of molecule. That molecules are called as interhalogen compounds. These interhalogen compounds has the general formula X, Y, N, or we can write here in this way also A, X, N. Okay, both are the same, where the N is equal to 1, 3, 5 and 7. Here what is the condition for the preparation of the interhalogen compound? The X, that means in first case the X halogen is less electronegative and having larger insides, and the Y halogen atom which is more electronegative than the X and the smaller in size. This is the basic condition for the preparation of the interhalogen compound. Let me learn the types of the interhalogen compounds. These are divided into the four types. The first XY, second XY3, third is XY5 and the fourth type is XY7. Okay, here this XY type of the interhalogen compound have the different examples, that is CLF, BRF, BRCl, ICl, IBr. Here one here only the two halogens which can be combined together. That's why there are the number of example and number of interhalogen compound which we can be prepared. Second is XY3. The examples are ClF3, BrF3 and ICl3. Here this is ClF3 which is in a gaseous state, BrF3 is a liquid state and ICl3 is a solid state. XY5 has the examples ClF5 which is in a gaseous state, BrF5 liquid state and IF5 liquid state. And XY7 has only one example to be discovered, that is IF7 which is in a gaseous state. Why only the one molecule is found in the XY type of interhalogen? Because fluorine is the smallest molecule, and that's why here this smaller atom which can be combines or which can be form a bond with the iodine. But whenever we use the another halogens, they have the larger in size, and that's why the repulsive forces increases and the stable structure will not be prepared. Next we learn the preparation of interhalogen compounds. The interhalogen compound can be prepared by the direct combination or by the action of halogen on a lower interhalogen compounds. The product form depend upon some specific condition. That we learn the preparation of that. First of all, the AX type or XY type of the interhalogen compound, it is prepared by the equal volume of chlorine and the fluorine, heating it at about 473 Kelvin temperature, we get 2ClF. Also, the I2 which is reacted with the liquid chlorine, there is a formation of 2ICl. Next, AX3 type of interhalogen compound is formed by the reaction of Cl2 with 3F2 which is in excess, heating it about 573 Kelvin temperature, we get 2ClF3. Likewise, Br2 which is reacted with the 3F2 with diluted with the nitrogen, it gives 2BrF3. Next type is AX5. Here the Br2 which is reacted with the excess of 5F2, we get 2BrF5. This is the preparation method. Let we learn the properties of interhalogen compound. The physical state, its molecules are covalent in nature. Color, this compound, most of the compounds are colorless. Boiling point, the boiling point increases with increase in electronegative differences. Thermal stability. Thermal stability decreases with decrease in electronegativity difference. And the reactivity, here the AB type of compound is more reactive than A2 and the B2 type of the molecule. Because of their AB type have a different size of the atom, that's why there is electronegativity increases and this molecule becomes more and more reactive. Let me learn the first type of the interhalogen compound, that is XY. Preparation. First example is the iodine monobromine preparation. It is obtained by the direct combination of the elements. This is the structure of IBr, which is linear. It is hard crystalline solid of a grey violet color. Its vapor dissociates to a small extent on heating. IBr is an electrical conductor when it is in a molten state. Let me learn the hybridization. Here this is a common hybridization of AX type of the interhalogen compound. This is same for all AX type of interhalogen compound. If here we take here the A and X both are the halogens, that's why the central atom is A, this, and this central atom has a valence electronic configuration is N(s)2 Np5 and here there is a Nd, N minus 1d, N minus 1d. Here these molecules, that is Ns having 2 electron and 3p having a 5 electron. This is combined. This is a ground state. In excited, there is no need of the excitation of electron because only one other halogen which is bonded to this central atom, and that's why here these 4 orbital, that is 1s and 3p orbital, which is combines together, and there is a formation of a new 4sp3 hybrid orbital. That means the hybridization of this molecule is a sp3 and the structure is linear and their geometry is tetrahedral. Why? Because the 4 atoms which is combines together, 4 orbitals which is participated in the formation of this molecule, but 3 have the lone pair of electron and only 1 is the bond pair. That's why the structure is according to the VSEPR, the structure is linear. Next interhalogen compound is AXY3 type. Example is chlorine trifluoride. Preparation. It is prepared by the action of Cl2 and F2 at 200 to 300 degrees Celsius temperature in a copper vessel. Properties. It is a colorless gas which condenses to give a pale green liquid. Hydrolysis. It is hydrolyzed by water forming ClOF molecule. Action of F2 and Br2. When ClF3 react with F2, it gets fluorinated with F2 and forming a higher interhalogens, that is ClF5. And when the ClF3 react with Br2 at 10 degrees Celsius temperature, we get another type of the XY3 type of interhalogen, that is BrF3, okay, and it is bent T-shaped. Let me learn their hybridization. Here the chlorine which has a valence electronic configuration, that is 3s2 3p5 and 2d0. Then what happened here? This chlorine which is bonded with the 3 fluorine, here it is bonded with 3 fluorine, that's why this orbital required 3 unpaired electron. Here only 1 unpaired electron is there, and that's why in an excited state the 1 electron from the 3p orbital which is excited to the d orbital, and there is a formation of excited state. Then these 3 types of the orbital, that is 1 s orbital, 3 p orbital and 1 d orbital combine to form a new hybrid orbital, that is sp3d hybrid orbital. This is the hybridization of the ClF3 or XY3 type of the molecule. This is same for all. That means XY has sp3 hybridization and XY3 molecules interhalogen compound has the hybridization sp3d. And that's why here they have the structure trigonal bipyramidal. Okay, here in this case the uh, here two are the electron pairs and 3 are bonding pair. This is also called as a T-shaped molecule. This is also called as what? T-shaped molecule. Okay, and the shape is T-shaped. Next we are going to learn the type, that is XY5 type of interhalogen. Example is IF5. It is prepared by the direct combination of I2 and the excess F2. Properties: it is a colorless liquid whose melting point is 9.6 degree Kelvin. It is a good conductor of electricity. It is hydrolyzed by the water to give halogen acid and the oxide acids of the larger halogen compound. Okay, next we learn hybridization. Here the iodine has the valence electronic configuration, that is 5s2 and 5p5. Here this iodine which is bonded with the 5 fluorine atom, that means it requires the 5 unpaired electron. That's why the two electron of the p orbital which is excited to a d orbital and we get excited state. Then the 1s orbital and 3p orbital and 2d orbital which is combines together, and there is a formation of new hybrid orbital, that is called as sp3d2 hybrid orbital. In this hybrid orbital only one is the electron pair and all are 5 are the bond pair. That's why the structure is square pyramid. The structure is square pyramid and the geometry is octahedron. Next we learn the next type of interhalogen compound, that is XY7. Example is IF7. How it is prepared? It is prepared by the action of F2 on the IF5 at 250 degrees Celsius to the 300 degrees Celsius. We get IF7. Properties: it is a gas at ordinary temperature. It is highly reactive and it is hydrolyzed by water, giving HF and H5IO6. Let me learn their hybridization. Here the central atom is the iodine. That's why the valence electronic configuration of iodine is 5s2 and 5p1. This iodine is bonded with the 7 fluorine atom. That's why for the iodine require the 7 half-filled orbital. That's why for this the electron from 2p orbital and electron from 5p orbital and 5s orbital is excited towards the d orbital, and the excited state is like this. All these 5 1s orbital, 3p orbital and 3d orbital combines together. There is a formation of the new hybrid orbital, that is called as a sp3d3 hybridization. The formation of IF7 molecule involving what? The sp3d3 hybridization, and this is a structure of the IF7. Here the structure name is pentagonal bipyramid. The geometry it is called as a pentagonal bipyramid, and here there is no any electron pairs. This is about the shape hybridization of the types of the interhalogen compound. This is the question for you. You must have to answer me. In one column there are the types of the interhalogen compound, and the second column they have their shape. X type always has what? The linear shape. XX3 which have what? Yes, this have a T-shaped structure. XX5 they have what? Yes, square pyramidal shape. And the IF7 which have the pentagon bipyramidal shape. Okay, this is the shape of the all interhalogen compound. Last, that is the uses of interhalogen compound. It is used as a non-water solvent. It is used as a catalyst and also used as a fluorinating compound. This is all about the interhalogen compounds. Next lecture we will learn the pseudohalogen compound. Thank you very much for watching my lecture. Please like it and comment it. Thank you.